Okay, folks, so we're just going to go through some of these notes. Many of you have done the homework questions already. You've worked ahead, so you can just quickly read through these as we're going through them. Okay, so global systems. What do we mean by this? One of the key words you hear a lot about is climate, as in climate change, and we're going to be looking at that in this unit. So we're going to define it as a trend in temperatures, atmospheric pressure, humidity, and precipitation. When people talk about climate change, a lot of people think it's just the temperature. No, that's only one component of climate. Now, that is counterposed to this word, or compared to this word weather. This is the day to day. So, at one time and place, what is the weather today? So, this is the day to day changes on all the things above here, like how much humidity or rain we're going to get today, things like that. Whereas precipitation over a year, that would relate to the climate. So climate is the big picture over thousands of years. Weather is the day to day. Yeah, and we're going to interactions of different components of the biosphere, what climate results from. So when we look at the word bio, that just means living areas. So this thin layer that supports the living life, okay? And Earth's climate supports life and impacts climate, changing climates. Okay, we're gonna look at that in this unit. And how have humans impacted climate? That's something else we'll look at in this unit. So very topical right now. So components of the climate, biosphere. So the first component, okay, so the biosphere consists of three interacting components. The first component is the lithosphere. Anytime we see this word litho, that just means rocks, okay? So the solid portion of where life can be found. And the lithosphere itself is that thin crust that we float on. It's about 100 to 200 kilometers thick. And then below that is magma that can spew out in volcanic lava. When the magma comes out of the ground, it's called lava. Okay, so the atmosphere, thin layer of well-mixed gases. And the third component of the biosphere is hydro. So all the liquid components of the biosphere. So the lakes, streams, glaciers, and so on and so forth. Okay, so let's take a look at them a little bit more. Lithosphere. Yeah. Okay, plate tectonics. That solid portion. Here it is. And in this case here, the crust gets pushed under or subducted another crust. So this is that first 100 kilometers, the lithosphere. Yep, and if we go down about a mile down underground, you find microorganisms still there. Warmed by the sun, but also by the melted material in the mantle. So heat coming up from the mantle. So this is called the geothermal heating, and solar radiation is the second form of heating. Atmosphere. Most abundant gas is nitrogen, followed by oxygen, and then we get trace gases like carbon dioxide, 1%. Atmosphere contains particulates like atmospheric dust. So we get beautiful sunsets in the fall when farmers are doing their plowing, burning their crops. There's life within the atmosphere, so we can find molds, bacteria, and viruses. Well, we know about viruses. They're definitely in the atmosphere. Earth's atmosphere is divided into 4 layers depending on the average air temperatures. So these I don't really want you to memorize too much, but I do kind of want you to kind of appreciate them. We're going to look at the where the weather occurs, the troposphere, that's where we live in. The stratosphere, planes can fly in there, that contains the ozone layer that's going to block the harmful UV radiation and convert it into heat waves. That's what the ozone layer does. Where is it located? In the stratosphere, the mesosphere, and then the thermosphere. These are the approximate distances of them. Okay, so let's take a look at them. Troposphere, average temperature about 15 degrees Celsius, but it can go up to minus 60 when we get up here. Okay, up here, air, as pressure decreases, it gets much, much colder. 80% of the gases, including higher concentration of oxygen. Stratosphere, minus 60 to 0. Well, this is weird. All of a sudden, the temperature starts getting warmer. Contains ozone, which blocks UV radiation. By blocking the UV radiation, this protects life because UV radiation, those high energy waves, they get converted into infrared waves instead. If they were to come through, and some does, it can give us cancer. And it can kill single-celled life like algae in the oceans. Okay, the mesosphere, from 0 to minus 160 degrees Celsius at the top. And then this thermosphere gets super hot. Well, why would that be? Getting closer to the sun? And the ionosphere is part of the thermosphere. It contains many charged particles. This is where you find what's called the northern lights. Okay, otherwise known as aurora borealis. And we get this attraction in the poles. So the north-south poles, we get ions being attracted to the charged poles. And so if you've ever seen the northern lights, it looks like you can almost reach out and touch them, but they're way up here instead. Yeah, okay. Large temperature changes not well understood. Okay, hydrosphere. 70% of the Earth's surface is water. The frozen portion is the cryosphere. So a big part of this water is taken up in the cryosphere, particularly in the South Pole. Antarctica, okay? Antarctica has a huge reservoir of Earth's water, frozen water. 23% of the sun's energy is used to move water around. So 1/4 of the energy creates the hydrologic cycle. Now think about that. Evaporation wouldn't have occurred without the sun's energy. So this portion right here, evaporation. So two forms of energy. Solar energy causes this, evaporation, and then gravitational potential energy causes this, the precipitation to occur, as well as obviously runoff. That's gravitational potential energy as well. So two forms of energy driving the hydrologic cycle, solar and gravitational potential energy. Altitudes and temperature. Generally, as the altitude increases, the temperature decreases. In areas near mountains, cool air can be trapped close to warmer area, and you get a temperature inversion. Pollutants can be trapped. Yep. And this process can affect people's health. Yep. Okay. So cities that are in valleys, they can have the cold air right here because it's more dense. It can actually trap a warm pocket of air, okay, with all the smog in there. Okay, now folks, you have done these questions right here. I'm going to ask you to do just a few more on page 355 and submit those.